Hi, I'm Adam Fans, the Planetarium Director at Bays Mountain Park and Planetarium in Kingsport, Tennessee. We are getting ready for an evening of observing, and you can see in the background that we've got a really nice evening set forward for us. And what we're going to be doing is learning about some constellations that you can find in your own backyards. And this is for our early summer time of year. And so you can go out in your backyards and learn about what's up in the night sky. We'll also be using a telescope to look at some interesting what we call deep sky objects, and things like galaxy or cluster of stars, double star, things like that, and learning about those as well. And hopefully you'll be able to find some of these objects in your own backyards. Well, here we're going to be learning about two very famous patterns of made with stars in the sky called the Big and Little Dipper. They're actually not constellations. Those are ancient dot-to-dot pictures made up with stars. They're actually called asterisms, modern dot-to-dot pictures in the sky. But these are very easy to spot towards almost due north, depending on which part you're looking at. But let's point them out. First of all, we're going to use a laser pointer. And you always have to be careful using a laser pointer. But we see the Big Dipper right here. The handle starts here, goes along here, and then over here is the scoop of the Big Dipper. These two stars are very famous. They're called the pointer stars because they point to the North Star, right down there. And it's also called Polaris. Polaris, or the North Star, is almost exactly due north. It's slightly off, but just by visually looking, you're not going to be able to tell the difference. But it is the end of the handle of the Little Dipper. And the handle is actually bent kind of the wrong way, where we go from the North Star, or Polaris, over to here, and here, and here, and down, and over, and here. These two stars are called the guard stars because they guard Polaris, the North Star, and the North Star is easy to find. But the rest of the stars, as you can see, are very faint indeed, and they're probably barely being visible in the recording here. Let's go back to the Big Dipper. And the star that here where the handle bends, that is actually not just a single star. It's actually not just a double star. It's a triple star. They are called Alcor and Mizar. If you have very good eyes and the night sky in your backyards, you might see a kind of a faint star to the right of the brighter star. Mizar is the brighter star. Alcor is the fainter one. Now, nice skies, good vision, you'll see two stars very close. Binoculars will easily resolve those two stars, so I do recommend doing that. And then if you have a telescope, well then Mizar turns out that it's a double star. Two very white-looking stars, and they're very close together, and you need a telescope to be able to spot them, to spot the two of them. So, what was thought of one is not even two, but actually three stars. And so once again, the end of the handle, Alcor and Mizar right there at the bend of the handle, easy to find. And then the rest of the Big Dipper. Now the Big Dipper is an asterism. It is part of a much larger constellation called Ursa Major, the Great Bear. The bear's tail is the handle right there of the Dipper. But the rest of the body goes way down over here, and his head's way down over here, which is probably out of the field of view. So this whole part of the sky down here and even farther is the rest of the body and legs of the Great Bear. What about the Little Dipper? Well, it's actually the Little Bear. If there's a big bear, there's a little bear. Ursa Major, Ursa Minor. But all of the Little Dipper is the same as the Little Bear. So the bear's body is the scoop of the Little Dipper, and the Little Bear has a long tail, just like the Big Bear. So These are two very easy objects to find. Actually, one is very easy, I should be honest. It's the Big Dipper is easy. The Little Dipper can be a challenge, but you probably binoculars, even in an urban setting, will show them. We're going to be learning about an asterism called the Summer Triangle. It's actually 3 bright stars made from 3 different constellations. It is not a constellation, it is an asterism, a modern dot-to-dot picture made up of stars. And they are predominantly seen in the summer sky and leading into the fall. But let's use this pointer here to point them out for you. And so high up above we find Vega. Down here we see Deneb, and over here, whoops, that was on the tree there, and that is Altair. And so let's go back up to Vega right here, which is actually part of Lyra the Harp. And over here with these 4 stars, we see a parallelogram representing the harp itself. The strings run up and down. Down here we find Deneb, part of Cygnus the Swan, and Cygnus is a very large constellation. Deneb's actually the tail of the swan. We're going to find his body, his long neck, and way over here, Alberio is his head. Let's go back down that long neck, and then we find his wings sticking out to there, to those 2 stars, and then down to these 2 stars for his wings on either side. Going back to Deneb, and let's go over to Altair. We're going to find that it's part of the head of Aquila the Eagle. Here's the head, and then we go down to this star, his neck. This is his neck. His wingtip is over here. Down here is his tail. Up here, over here is his other wingtip. There's his neck. Here's the head, and there is Altair again. And so we see Lyra the Harp on the top, Cygnus the Swan on the lower left, and on the lower right we see Aquila the Eagle with Altair. All right, we're going to be learning about the constellation of Scorpius the Scorpion, and I'm going to use a green laser pointer here, which you have to be real careful with, that you never point it at anybody, and especially not at a plane either. Here we can see our laser pointer, and we're going to be pointing towards the pincers of Scorpius up in front. And then down over here is his body, that's Antares, that red star I'll talk about in a second, and his tail, and over here is the stinger, that brighter star right there. So we have Scorpius the Scorpion, right over here, his pincers again, long body, long tail, and stinger. And Scorpius is one of the more prominent constellations. It is part of the zodiac, which is the apparent path the sun makes across the sky. The ecliptic runs through the zodiac. And with Scorpius, we saw Antares because actually the name is called Antares because it looks like Mars, but it's not Mars. So the word Antares means not Mars. A very easy constellation to find. It looks like a very large fishhook in the sky. Well, here you can see our telescope here, and you can probably also notice that the sky's kind of bright. The moon is up, but what we're going to be doing now is using our telescope, and this particular one has what's called go-to feature, where you use a paddle that has a little kind of a computer interface to tell it where to go, where to point. I will say that even though you may see telescopes out there at the beginner level that have go-to, it is not as easy as it sounds. It takes about a half an hour just to get it set up and to get it aligned with the night sky. It's It's good for finding objects that are so faint that you may not even visibly see them in a telescope, but you want to be able to photograph them. But quite honestly, learning the night sky just takes a lot of time, learning how to use a star chart and being able to find your way around, and what's called star hopping, where you start with something bright, bright star or pattern, and then you go from there off to the right or the left by a certain amount, and you'll eventually find what you're looking for. And it takes a lot of time. But for this, I'm going to be using this go-to feature. It's kind of noisy, but let's go. We're going to be pointing over to a star called Vega in Lyra Bahar. This telescope is set up as a equatorial mount, which means that it has two axes in which it will rotate, one of which is right ascension, which is kind of like the clock dial of the sky, where it, as the Earth rotates, spins like a top. Right ascension is in that same direction. And then the other is called declination, which is how far north or south of the celestial equator in the night sky. And so we're seeing our telescope move in those two directions and pointing to that star. We're going to now look at a number of what we call deep sky objects that was taken with my telescope. And I will preface that some of these images are okay. Some of them are not as good as I'd like. But if anything, they do show what they would look like through a telescope, as opposed to a very long exposure that was highly processed and specialized. So in that sense, it is serving that purpose. Here we see an open cluster that is called M29. When you hear of a deep sky object with the letter M in front of a number, it means it's one of a list from Charles Messier. He was a French comet hunter that lived in the 18th century, and he made a list of objects that were not comets. These faint fuzzies that he'd see through his telescope, and these objects were things that he wanted to avoid, and so he started making a list of things that weren't comets so he wouldn't get confused as to what he saw. So this is the 29th on his list. The numbering scheme has nothing to do with the objects at all. In fact, he didn't really understand probably half of the objects that he was finding. It was just a list of things he didn't want to see. So turns out they're the 100 best objects to see in the night sky, because they are relatively bright and large enough looking in the sky that we can see them sometimes naked eye, sometimes with binoculars, and sometimes with telescopes, but you don't need a big giant telescope. It's nothing so tiny in the sky or rare or esoteric. So these are the easy things to find. M29. This particular object is an open cluster, which means it is a cluster of stars, and that means that those stars formed in the same area of space altogether at the same time. And so you can see in this image kind of a gathering of brighter stars near the middle, and you see a whole bunch of other stars that aren't as bright in the background. So this is a small open cluster. You're going to see a few dozen brighter stars, and so all the other stars are way in the background. They have nothing to do with the cluster. They're just part of our galaxy. And the open clusters are found along the disk of our galaxy. Sometimes they're called galactic clusters. And they range in sizes. Some are just a few dozen stars, some a few hundred, some are a few thousand. But that's about their limit. And they just kind of form in the spiral arms of our large spiral arm galaxy, and this one is M29. And to find it, it is where the wings cross the body for Cygnus the Swan. It's very much in that kind of in that corner, that nook, and you should be able to see it with binoculars, but it's going to be pretty small looking. Over here, we see another cluster of stars, which is also in Cygnus the Swan. It too is an open cluster, and I'm not even showing all of the stars here, but you can see a very definite brighter star grouping, kind of spread out in this group. And there's actually some stars that are outside of the field of view. But again, another very loose, open cluster of stars. This one is M39. Here we see something completely different. It is called the Ring Nebula. And this one you do need a telescope to see. This one, as you can see, it's a little ring, and it's a smoke ring in space. It is what will happen to our sun in the future. All stars form out of large regions of dust and gas, and the gas and dust coalesce and end up forming a star, which is a big ball of gas. In the center is the nuclear fusion, in which the star needs to shine, and the gravity of all of that mass of the star is always squeezing inwards, but the nuclear pressure of the generation of energy and light and heat is pushing outwards, and that's why stars are round like balls. This is what will happen to a smaller sized star when it dies. The star, through its cycle of converting hydrogen gases to helium, and then eventually it converts helium into other gases and so on, there is a point in which it can't create new gases and keep fusing those atoms into heavier atoms. And so when that happens with our sun, when it starts getting up to iron, then what will happen is that it becomes unstable. The star becomes unstable. It starts to collapse, and when it does, it then compresses very strongly, somewhat quickly, and it puffs out this outer shell of gas. So the outer parts of our sun, when this happens, will be pushed out into space, into a big smoke ring in space. And there's a whole variety of these types of objects. They are called planetary nebula. And you can see that it kind of looks like a planet in a telescope, especially if you're using very low magnification or just didn't know what you're looking at. But it's actually the outer shell of an original star in the past that was blown out into space. The core of the original star is actually still there, and if you zoom in, when we zoom in, you can see a little dot in the middle there. That is what's called a white dwarf, and that's the remnant core of the original star. And so we can see the smoke ring in space. You can also see some colorations. Those are different gases, different elements reacting to high energy and fluorescing in different colors. And this one is in Lyra the Harp. It is called the Ring Nebula. It is also known as M57 for Charles Messier's list of things that were not comets. And it's in Lyra the Harp, kind of at the far end of the parallelogram of stars that make up where the strings go across for the harp instrument. Here we see a galaxy. This is an Ursa Major, the Great Bear, also the Big Dipper. And if you look at this structure of this galaxy, you can see that it's a spiral arm galaxy. It is kind of a loose spiral. You can see the individual arms. You also see that the image looks kind of rough. There's a lot of background noise. The moon was up when I took this image, and so it was really washing the sky out. And so it just I really had to play with it in order to pull this out. And binoculars will show it as a very faint little fuzzy, but a telescope will show this general structure, especially if it's dark and there's no moon up, like when I took this picture. But Our galaxy is a spiral galaxy. It's actually a barred spiral galaxy. Traveling through a lot of empty space, we eventually travel to other galaxies that are millions of light years away. And this is the Pinwheel Galaxy, also known as M101. You can see also, I should mention, you see how there's brighter sections in the arms and little knots of brightness, and then in the center it's very bright and white. Well, those little knots of brightness along the arms are star-forming regions. So as what's called a density wave passes through the galaxy, passes around through the galaxy, it will disturb dust and gas that's part of the galaxy, but we're not physically seeing it, and eventually disturb it enough that it allows the gas to start collecting and creating new stars. And what we see is the aftermath of the gravity wave or density wave as it passes through, and we see the spiral arms made up of stars that had just formed, and that's why they're bright, and we can see them easily. And you also see that they're kind of in clumps. In the center is the core of the galaxy, and that's where you just get a lot of stars. They don't touch, but there's a lot more stars there, and so that's why it looks so bright in the center there. Here's another galaxy. This one looks a little strange, and it is all from the center, I know. This one is called M82. It's also it's in what we call like a it used to be called an irregular, which means it didn't have any real structural shape to it. It just has this strange structure, but it's now called an active galaxy, and it is a starburst galaxy, I should say. And you can see the bright spots in the center there, and that's where there's a lot of starburst activity occurring with a lot of star formation all at the same time, but it still has a very loose and rough structure. It's not so organized looking as the spiral arm galaxy. And so it has also that dark band in the middle there. So this is another object, another galaxy in Ursa Major, the Great Bear, or the Big Dipper, and it's called M82. We have two more objects. Here we see a globular cluster. Remember, we talked about open clusters, very loose gatherings of stars, all formed in the same region of space, maybe a few thousand stars at the most. This is called M13. It's in Hercules, which is high up and starting to go over towards the west as the summer progresses, and can be seen with the unaided eye in a dark sky. Binoculars definitely show it as what it looks like, a little fuzzy ball, kind of a fuzzy star. And then a telescope will obviously show it. And we can see that it's made up of a lot of stars. This one has about 1 million stars in it. And no, the stars do not touch in the center. They're all individual. But you can see that structure. It's like a whole bunch of stars in a ball shape that are all orbiting the center of that globular cluster. These are very ancient. They formed at the same time as the formation of our galaxy. Like I said, these are very old stars. There's not really any star forming occurring anymore. What's happening is that the stars will eventually just all die out. These are very neat looking. These can be found not like open clusters, which are only found along the disk of our galaxy, but these can be found anywhere in the sky because they orbit our galaxy in all sorts of different directions, above, below. Sometimes they happen to be seen along the galaxy, but that's where we can find these. And this one is in Hercules called M13, and it's a real showcase in a telescope. The last object is something that we always use last if it's up, if you're observing in your backyards, and the reason being is you don't want to kill your night vision. We're looking at the moon, of course, and we can see the moon's craters very easily. And you also see dark and light markings. The dark areas, those are called maria, and that is Latin for seas. People thought the moon was like the earth and that those dark areas were oceans. Sorry, they're not. What they are is lava plains. And so what happened, if you also notice, you notice how the circular areas are, the maria are circular in shape. And that's because they are formed from very large impacts in the past. So you see the craters that are smaller all around. Well, imagine a rock so big that it made a crater as big as these large dark circles. Huge impacts. So much so, and so long ago, billions of years ago, when the moon still had molten lava down below the surface, um, when the impact occurred, lava from below came up through the cracked surface and then filled in the crater that was formed. And that's why you see them as these large circles. Um, and you can see that they range from, somewhat smallish size, and then some are kind of medium, and then along with the day-night boundary line, it's called the terminator, actually. You can see a couple of very large ones, especially the one up in the top left. And so very large maria. And so you're seeing lava, which is also basalt. We see it here on Earth, we see it on Mars, it's all over the place. So it's very common rock, and especially with lava and magma activity. And then, of course, the craters. And we see all craters of all sizes. And as we zoom in, we can see lots of structure. Some of the craters have a central peak, and that's because when the impact occurred with an asteroid from space hitting the moon surface, it instantly liquefies the surface. And so in that area of the impact, and we're only talking about maybe up to about 2 minutes, that it's liquefied for about 2 minutes, in which then it splashes outwards. So imagine like a milk drop. You drop a little bit of milk onto the water, or rock into a pond. It creates this round crater shape, but because it's not water, it's the moon, it then splashes back in towards the center, and then you get this central peak formed, and it splashes out again, and sometimes it splashes back inwards to the center. It bounces around a couple times. And so the bigger craters are actually having multiple rims and multiple central peaks. Smaller craters may just have one central peak. Really small craters don't have any. They just impact, they blow outwards, and then they solidify. So within seconds to maybe up to 2 minutes for the largest craters, it's liquefied and then it solidifies and kind of freezes in motion. But you can see all the cool structure that you see. And the binoculars are really a great way to view the moon. You also see some ray structures, those kind of whitish lines shooting across. Well, if you trace them, they go towards a large crater impact, and it is ejecta. So when the impact occurs, this material gets shot out into space in a very far distance, and then lands back onto the moon, and it makes these ray structures. So they're actually, so imagine like if you threw a rock into a dish full of flour, and that flour just shoots out all over the place and falls down to the ground. And that's what this is like, those ray structures. You also notice a little color difference in the Maria. That's because there's some different element compositions with the moon. It's very subtle to see that, but it's there. Um, so, the moon's a lot of fun to watch, to look at with binoculars, and you'll notice the phase of the moon in this particular image is a waxing gibbous phase. It's a little bit past first quarter. Some people call it half moon, but it's really first quarter. But we're seeing a gibbous phase in this image. If the moon is close looking to the sun in the sky, that means that we're going to see it as a crescent phase. And really, what are we seeing? The daylit side of the moon. In this case, on the right side, we see the daylit side. We see the terminator, which is the boundary between day and night. And then we see no moon. We don't see the moon, but that's just nighttime on the moon. There's no atmosphere on the moon, so there's no twilight. If you're on the terminator, or if you're around the terminator, and the moon is rotating, and then you have sunset occur, it goes from day to night instantaneously. You can actually see the shadow of the sunlight pass across you at your feet if you were there. So lots of neat things to see in the night sky. So do try to get out in your own backyards this summer. Try to find some of the constellations that were pointed out, and just have fun and enjoy the night sky. And use those binoculars if you have them. Thank you.